Our next session will look at spectrum needs and applications, future spectrum needs and applications. New entrants come in to push the boundaries in existing industries. There's a greater demand for spectrum to enable operations. Existing spectrum users therefore need to make room to expand bandwidth to allow for innovation, but that brings particular challenges for all stakeholders, industry, regulators, operators. This is what Laurent will discuss with his panelists. Laurent is a senior expert for navigation systems at Airbus and also a long-standing member of the Eurocontrol Technical Advisory Committee. Over to you, Laurent.
Thank you very much, Anna. Well, welcome. Good morning, good afternoon, everyone. I'm very pleased to be with you today to moderate this session, very important session. Well, just a few remarks in a few seconds. As a representative of the civil air transport, you heard that yesterday, we are all facing the introduction of new telecommunication services, and we need to adapt, for instance, for the 5G C-band for radio altimeter. But at the same time, we should also think about the future and welcome new entrants, new applications, and new services. And so some of the keywords about that are adaptability, efficiency, obviously safety, but also collaboration with telecommunication and coexistence. And today I have a great team of panelists that will introduce us to the future spectrum needs and applications. So first of all, I would like to introduce Gary Bertz from Eurocontrol, Boris Resnick from Flyvercity, and Davis Hackenberg from NASA. And so this team of panelists will introduce you their views on the future spectrum needs, and then we'll go to a short, small debate and some Q&A. So Gary, back to you. I leave you the floor to introduce the subject. Thank you.
Yeah, thank you, Laurent. Hello, everyone. You did mention the radio altimeter. I hear that was also a big topic yesterday. One of the, let's say, few good things that come out of the debate is that the topic all of a sudden caught senior level attention. So all of a sudden I had our Director General of Eurocontrol actually ask for a paper on spectrum. As that, we tried to set things into perspective between the telecoms and aviation industry. And when you see in this table the global spectrum allocation, we are actually quite similar in size, using a bit over 2 gigahertz of spectrum. The telecom colleagues, many of them are saying, look, almost every other industry has given spectrum to us for telecoms. Why haven't you? Now, if we look at the size of our industry within about 3 dBs, we're roughly the same size. You will see that tax revenues generated are a bit higher on the telecom side. And you'll have to add on top of that money made in spectrum auctions, the revenue from those auctions. So we asked ourselves, is aviation really innovative and able to innovate? And the answer is yes, very much so. But this is primarily the case when you talk about new engine, more fuel efficient engines, better airfoils, etc. When it comes to CNS equipment, you need to look to the market makeup. And there you see that telecoms has a lot of, compared to avionics, relatively cheap devices that have a short life cycles, while we are stuck with a few expensive devices with a very long life cycle. And so that inherently makes it very difficult to replace CNS avionics. An interesting comparison you see on the side also about how we are represented in ITU. So unfortunately, this is a bit of a David versus Goliath fight, if I may use that expression, and that we are really not well represented, even though we are a major spectrum user. There are about 192 ITU and ICAO member states, and so we are well below one person working on spectrum per state. And if we would increase that number to one person per state on average. Obviously, the smaller states might have to pool resources, but the larger states should really be present in much higher numbers. And really, the only positive exception here is the United States and a few European states that are present at ITU. But you all have heard the saying, you get what you pay for. In this case, aviation is getting what we're not paying for. And so to me, the question is, how much are we willing to pay to actually preserve that benefit? Next slide. So we did a think paper on that where you will find that table. There are more details in that. But the point is that we actually have, under ITU radio regulations, not only the protection, the safety protection that is afforded to us, but we also have an obligation to apply the latest technical advances as soon as possible, which is where you quickly get into questions about, well, what is as soon as possible? To get back to what the telecom industry perceives, we did a study contracting in particular with a telecom organization, and they said if you would use state of the art, you would do all of CNS with about 20 megahertz. That already includes some redundancy. Now, we don't actually agree with this number, but the important thing to remember here is that this is the perception of telecoms. So to try and improve, next slide, we thought about what we can do. And as you see in the radio altimeter debate, one of the most important things is that you have to do as good adjacent band filtering as possible. But when it comes to life cycles of equipment, well, what is as soon as possible per ITU radio regulation? Well, if you take an aircraft life cycle of 20, 30 years, and you have avionics that live longer than that, many of them, the ILSs, VORs, DME, VHF, COM being designed 50 plus years ago, well, you have all had to update parts. You all have to deal with parts obsolescence. And if we can't even update avionics on such cycles, it is difficult to say that we are doing things as fast as possible. And then we have this other tendency where we develop new systems, but then don't manage to actually succeed in the transition. We had GBAS replace MLS, and now GBAS is struggling. We have proposals for a new telecom, for a new comm system, LDAX, that is struggling to get into the industry. Next slide. And I think this struggle is because, well, so far equipment earns its way onto the aircraft with operational benefit. But we are a mature industry, so we can pretty much do what we want. There's still a few improvements that we can do, but really to replace a piece of avionics due to spectrum as a driver is not something that we have done so far, and that's really a place where we need to get to. Not only do we have new entrants, but for example, I take the DME band. If we want to accommodate LDAX, new drone services, whatever, well, currently we suffer from congestion. So first, to actually accommodate new entrants, we need to make space, and already that needs an evolution. We also have a need for improved security in aviation. We are open system, and that too will take spectrum. So these are the drivers that need to change, where it's no longer just operational benefit, but that we need to be really more systemic and also look at how spectrum improvements can actually drive CNS innovation. Thank you.
Thank you very much, Gary. You tackled a very important point, and I'm sure it's going to drive some question. At least it raised some questions from me. So now I leave the floor to Davis Hackenberg from NASA. Davis, sorry, back to you.
Yeah, thank you. Yeah, I want to say thanks to Paco and Gary as well. Great briefings to open this up. Thanks to our TCA and Eurocontrol. I'm Davis Hackenberg, NASA's mission manager for advanced air mobility. Had an opportunity to work with our TCA for about the last 12 years, and both their CNPC 228 work and detect and avoid, and also some time with Eurocontrol. So really appreciate everything that's happening there. I know NASA and all the research and aviation community is on board with what you guys are doing. Just real couple quick sentences on NASA, like in an overview sense on this topic. Obviously, I'm in the aeronautics group, but there's a lot going on at NASA with respect to spectrum, COMNAV surveillance information, even on the space side, operational space technology development, a lot of innovations always coming out of our organization, and a lot of the subject matter expertise that we dig into in the aeronautics group comes from space ops, space technologies, and even the science mission directorate. Sitting within aeronautics, we've got four main kind of like mission areas that we focus on. One of them is commercial transport, a very well-established industry, and always evolutions going on with respect to CNS. We don't have a huge CNS portfolio focused on commercial transport, but we do have a revolutionary aspect where we're always looking at new technologies. Another one's supersonic, hypersonic, so high speed, if you will. Again, not a ton in CNS going on there. At some point, I imagine if those technologies mature and enter the market, we'll have a lot to consider with respect to their operations and designs and everything. The other two are heavily CNS focused and dependent, though. Airspace and then my mission, advanced air mobility, have huge dependencies on COMNAV surveillance. So on advanced air mobility, kind of code word for emerging aviation markets, if you will. We talk about three main application domains: urban air mobility, which is really our core focus due to the high barriers to entry in that market and some of the ways we think it'll scale. It gives us an opportunity to look at kind of the future needs of a system and maybe their maximized sense, and gives us an opportunity to optimize towards that. There's also regional air mobility and low altitude air mobility. Low altitude's another domain that is huge for COMNAV surveillance and major innovations, and all of those are within our mission. We take a really comprehensive systems engineering approach to those. So we start with ConOps documentations that really focus on the visions of those systems, where they need to go to be scalable and provide the most benefit to the most citizens in the United States specifically. Take those ConOps, derive those into top level requirements, and then build reference architectures that we can go kind of test and implement through our modeling, development, simulation, and test and demonstration environments. If you go to the next slide, please. A lot of that work has led us to where we're at today. It's a very initial architecture. The one that you're looking at here is specific to UAM. We have a complement to this for low altitude mobility, UTM, if you will, as well. And then regional mostly is leveraging a lot of the services of today and very parallel to other remotely piloted work that's going on in RTCA. But I'm going to focus on the UAM for architecture specific here for a minute. Our resource portfolio is really broad. A lot of work going on the vehicle design side, so acoustics, safety, flight controls, weather tolerance, things like that. Mostly not that relevant to COMNAV surveillance and spectrum specifically. A lot of the communications done wire to wire on board the aircraft. But as we get into the rest of our research portfolio that you can see represented here around, like vehicle operations, automation, pilots, operators, things like that, huge dependencies on COMNAV surveillance. A lot of our airspace integration work. So again, that extensible traffic management started with UTM, kind of expanded out to be part of high altitude, long endurance, urban air mobility, and other environments that we think these concepts of third-party services will extend to. Vertiports, highly dependent on CNS infrastructure, for surveillance of the vertiport, for communications to aircraft, relaying messages on safety and so on and so forth. In-time aviation safety management systems, we think, are going to be a huge part of this architecture. Lots of different services that will have spectrum requirements associated with those that we're looking at. And also the community integration piece, maybe more associated with the vertiport side, but a lot of spectrum surveillance equipment that's going to need to be installed, across our urban environments to really support this aviation system long term. So again, essentially what we're doing on CNSI is taking a comprehensive look at the future of what it needs to be for advanced air mobility, and again, in this case, urban air mobility. Kind of looking at this arrow by arrow, line by line, communication by communication, and understanding, how that communication, nav or surveillance is going to be performed, write requirements for that future state, assess the spectrum needs for that, and really come up with the innovative solutions that we're going to need in the future to solve these problems. Many of it, I heard Paco say earlier, no aviation without CNSI and no CNSI without spectrum. Kind of want to foot stomp that. It's huge. We have so much, as Gary said, so much going on in the spectrum and CNSIS. I like that added spectrum piece to CNSI. I'm gonna figure out what to do with that internal. But so much going on today that we can leverage. Obviously VHF has been a part of the system for a long time. Probably will stay a part of the system for a long time. But we know we're going more digital, right? So VHF there is something that someday hopefully can be more obsolete for these future digital aircraft. But many of the other technologies where there's spectrum allocated and assigned, maybe in single purpose solutions, could go through a list: GPS, DME, landing systems, ADS-B. A lot of this stuff will be part of our future system as well, we expect. But there's also a ton of new needs that this future system is going to have. Gary talked about the emerging avionics. I'm showing here kind of the PSU, provider of service for UAM, as the centerpiece to this. ATM is going to evolve, obviously, is what we're saying there. The security piece was mentioned. CNS is just such a backbone. Some of the other new things, beyond the PSU, things like V2V, pilots communicating to each other either through voice or through digital, more cooperative collision avoidance, CNPC is a huge piece. Relays maybe in the V2V sense, but then in the air-to-ground sense, we know that for these future aviation systems to scale and to be most efficient and profitable, that automation, remotely piloted end-to-end concepts are going to be a huge part of it. So we're going to have to look through all of those requirements. Some could actually give us benefits, have us need less spectrum as we automate more. But really what the heart of this system is talking about is a info-centric digital system where more and more information is going to need to be shared and relayed and processed by human brains and computers to make this a very long-term efficient solution. So we're looking at areas where we can get new spectrum. LTE's already been mentioned, and then obviously areas where we can do less single-purpose stuff, maybe combine spectrum, be more efficient, more state-of-the-art, and we're doing that through that systematic approach that I mentioned earlier. Understanding the full set of requirements as we can see them. All of this will obviously evolve as we get great inputs from our technical communities, do research, simulations from our subject matter experts. But we plan to continue trying to find those ways to optimize this, work through our state with ITU, like it was mentioned, to make sure that we maintain the spectrum we have and get access to more spectrum where we need it. And in a lot of cases, we operate under safety critical of today. Maybe in the future that will be consistent. Maybe we'll have more where we can do things not on safety critical spectrum, and definitely for the non-safety critical stuff that aviation will need in the future. I think as our services proliferate and if it becomes more of an more urban, more of a daily practice to leverage these advanced air mobility concepts overall, I think we're going to have more of a customer user base that needs access to spectrum that isn't safety critical to do things like work on your phone on the way to work or fly from a regional area to get and stay connected. So a lot to consider. Just kind of showing you an initial architecture and really looking forward to continuing this conversation with all of you. Look forward to your partnerships in the future and then any questions you have at the end of these set of presentations. Thank you.
Thank you very much, Davis. A very good overview of the capabilities, the needs, and the evolution, especially for the UAM side. So now we welcome Boris Resnick from Flyvercity, who will give his words on the topic from the US UAM perspective. Boris, back to you.
Thank you, Laurent. So I'm Boris. I'm CTO for Flyvercity, a company that builds unmanned traffic management services based on cellular infrastructure. And also I lead Eurocontrol activities on command and control for unmanned systems. So I can speak a little bit around this. I want to focus now on a specific segment for new entrants. And these are unmanned systems, either unmanned aviation systems or urban air mobility vehicles operating in very low level airspace, doing beyond line of sight operations and primarily in urban environments or suburban environments. This particular segment may be quite narrow in comparison to the whole aviation as was described by other people, but the number of entrants in this airspace is expected to be much higher, probably by several orders of magnitude higher in the long term. And then this fact influences the needs of the spectrum quite significantly. So as we know, nowadays rollout of new cellular technologies such as 5G is ongoing, quite active. A lot of investment is made in 5G infrastructure and also in existing 4G infrastructure. And this is driven by non-aviation use cases. And that gives us as an unmanned aviation community an opportunity to leverage this rollout and use these networks, new networks and their new capabilities to enable urban drone flights. So here we need to emphasize that on the cellular communications, we need to understand that these are defined by 3GPP, so generated partnership, and this is generally called cellular communications. And for me, this is the primary enabler, a key technology to enable BVLOS urban air mobility operations. And there are multiple functions that we need to enable to fly over the cities, and David has touched upon this, but here I want to split this into domains. Generally speaking, ground to aircraft communications and aircraft to aircraft communications. These are quite different in terms of spectrum needs. So for ground to aircraft communications, the primary function that is enabled by these comms is command and control, or command and control and communication, depending on the type of operations. And there may be several others, but this is the most important. As we know, ICAO produced a guidance, a new version of SARS, that defines several aeronautical bands usable for command and control, including C-band and L-band and some number of frequencies. But these frequencies do not cover cellular communications, in the sense that we do not here want any dedicated spectrum. What we really require as an unmanned community is to use already deployed networks, primarily public networks deployed by major mobile network operators. And this is a licensed spectrum, but not an aviation spectrum. And as such, it is not covered by this ICAO mandate. But as we speak about urban operations in a segregated airspace and very low level airspace, probably the risks for unmanned systems are a little bit lower. That's not applicable for UAM, but still. the primary spectrum need here is not an allocation of new bands. The primary need here is an endorsement of aviation regulators for usage of licensed cellular spectrum owned and operated by cellular operators for aeronautical purposes, assuming that proper safety mechanisms that exist in cellular networks would be employed to protect these communications from the reliability standpoint, from security standpoint, and other aviation-based requirements. So this what I want to emphasize in regard to air-to-ground communications. From the other side, we also have other functions that are based on what we can call here air-to-aircraft communications. Sometimes these things are referred by aviation community as broadcast communications, things that are similar to ADS-B on 1090 megahertz, but probably for cellular communications that would be more correct to call this aircraft-to-aircraft communication. And these communications would enable multiple functions. So the functions that I want to mention here is detect and avoid, cooperative detect and avoid function based on these aircraft-to-aircraft communications. And this probably may include, as Davis has mentioned pilot-to-pilot, voice, or rather digital communications, probably not voice to a less extent, but digital, and maybe other functions. But detect and avoid is the most important. For this function, there is no allocated spectrum today, and smaller unmanned system would require a dedicated broadcast band for it, because usage of things such as 1090 megahertz is not really endorsed for smaller systems. The count of them may be very significant. The number of flying vehicles simultaneously flying may be high, and that can saturate 1090 megahertz, so that is not endorsed, which is kind of a well-known point nowadays. So a special band might be required. So on the contrary to ground-to-aircraft comms, the need from unmanned system in this regard would be a dedicated band for broadcast and multicast to enable these capabilities. So these are two key needs from this segment, a very specific segment, but if we talk about new entrants, these would be the most promising and most the newest segment of all, and the least explored. But here, how at least it is seen by the community, or at least how I interpret this. Over to you, Laura.
Thank you very much, Boris. And now I would like to invite all the panelists to the stage, and we can start to the debate, or at least the Q&A session. Well, I think I will start first, and of course we welcome the audience to ask any question, and that I will be glad to relay to the panelists. So Gary, you started and you mentioned the 5G C-band situation. And before looking ahead, maybe we can learn some lesson from what happened. So what is your view on this situation? What can you learn from it? And actually, do you believe that this is something that could happen in Europe? Because currently it's a situation that is most intense in the United States, but obviously 5G C-band is deploying everywhere in the world.
Yeah, indeed. Thanks, Laurent. My answer would be is that this situation is happening in Europe already. And a lot of very good technical work is going on in the US, but the issue is really one that is global, and it's one that is difficult because here we have an avionics self-contained system. The radio altimeter only needs to be interoperable with the ground that the signal bounces off of. And a very typical case where it's difficult for aviation to complain about 5G because we're talking about compatibility issues that are 500 megahertz separated. So here's really where we have to focus on maximizing our adjacent band filtering. And it's great to have seen the avionics industry turn around and engage in this debate, and that's really what needs to happen a lot more. We had very interesting discussions when some of the radio altimeter experts started to participate in the CPT, the European Radio Regulatory Forum. And the telecom guys were using their acronyms, and us aviation guys were using our acronyms, and we're just not used to talking to each other. And to actually build mutual confidence, there's a lot of mistrust on both sides, to start a dialogue that actually tries to search a solution jointly based on the principle of reason. What I like to say is, yes, there is such a thing as reasonable filtering. Aviation needs to improve, but there's also such a thing as reasonable power level. So there we need to find a good compromise, and that is really where we need to learn to engage in each other's forums and processes, because, you know, this RTCA EuroK is already a big machinery that has its rules. CPT, ITU is a big machinery that has its rules. And to get people to make the links is we need a lot more people that make those links.
Thank you, Gary. So, well, I would like to ask a question to Davis, because you mentioned a lot of components of the US world that seem to be very similar, but looking at the situation we face, for example, with radio altimeter, are you looking to reuse exactly the same technology or the same components, or you envisage that the CNS backbone for US UAM can be different, can differ, or maybe take the opportunity for these new entrants to evolve, because it will be, well, as a leader of new entrants, they will lead to change.
Yeah, I mean, I think the way that I'd answer that is obviously we want to come up with the best of the best for these, you know, for the solutions that we're about to, you know, build and design and over the next decade together. I think like I was kind of preaching in my talk, like, I think it's really important to understand what the future of these systems needs to look like, right? And from a requirements perspective, top level, how much spectrum do you need? What functions need to, you know, have spectrum associated with them? And then take a look at what we have, and, you know, do that crosswalk, if you will. I think it's pretty obvious, though, to most of us in the technical community that there's going to be some hybrid. We're going to be able to reuse some of what we have. It works well. Why fix it if it ain't broken, right? Some of that, though, could require optimization of the current systems we're using to add more data to them and add maybe more functions onto some of those current links we're using. In other cases, there's brand new spectrum we're probably going to need to do this. If you look at some of the non-safety requirements, like I mentioned, there's definitely going to be new things that are necessary, and that's going to require new approaches for us to look at. And you know, assessments of just the radio altimeter example is a perfect one, right? Like for the future of this, leveraging LTE as part of these systems. And then I do think personally, and I think many people in this ecosystem think that some of the spectrum, like LTE, is going to be a part of that architecture. I don't want to go forecast that or anything. I think, you know, you let the engineering and the research play out and come up with those ways, but you have to be thinking about those types of things now. Those are really long lead research items. I don't think that the cellular community has really put the rigor yet into designing a set of aviation compatible radios that meet the safety standards and requirements the way that we do it. Probably they're, you know, the best thing that mankind has ever seen with respect to connectivity and communications. And I mean, I'm happy with the reliability, right, as far as it goes on my phone, but that's a totally different question when you get to aviation, making sure it's safe, secure, things like that. So I think we have to look at it all. I think there's going to be definitely revolutions needed as well as evolutions needed to all of the different components of today.
Thank you, Davis. And actually, you really touched the point, and that actually raised some question also in the audience. And I will ask the question to Boris, because this is also a burning question in aviation. So how do you think that you can plan to have safety ensured, for example, for C2, C3 link, or apply the same standards that we have in aviation for UAM using cellular communication links that are, let's say, public standard and not designed to support aviation safety in the first place?
Yeah, thank you. That's an important question. And here, I need to emphasize that there is a kind of misconception about capabilities of modern cellular networks in general, and especially of 5G networks. So as for protection of the spectrum, yes, public cellular networks use protected spectrum. And actually, this spectrum is already used for safety critical applications in other verticals. As for aviation applications, there is a process of standardization going on by a cellular activity that is joint activity between EUROCAE and RTCA, and in cooperation with the activity called ACJ, Aerial Connectivity Joint Activity of GUTMA and GSMA. And this community works on establishing an aviation-grade safety requirements for cellular communications based on existing RTC standardization, that is command and control MASPs D0377, and things like integrity, continuity, availability, latency, aviation-grade performance requirements as directed by ICAO approach of general performance-based requirements are projected to cellular communications. And here, what is important that it does cellular communications used for aviation applications. It doesn't mean that people just stick a SIM card in a modem and fly. This communications uses an isolated network segment, which is safe and secure, and in general reliable enough for command and control or any other application coming from aviation.
Thank you, Boris. Yeah, go ahead, please.
Yeah, just add one note real quick. You know, even if it's, you know, not aviation protected and everything, you know, isolated, all those are great terms. There's always backup methods, right, that can be aviation protected and may not need as much spectrum, reliability for, you know, in a contingency situation and stuff. So there's even more to it that we, you know, we'll add on over time to leverage these new systems, I think. But great answer, Boris.
So I would like to kind of asking the same question to Gary. I mean, Gary, you are closer to the regulator, let's say, in charge of aviation safety in Europe, and you share the same view, especially when we talk about using this kind of network, not only for new entrants, but also potentially for aviation, existing aviation. What do you think, Gary?
Yeah, that's a very interesting question. And what I want to highlight also based on what Boris and Davis said, you know, there are many things that are technically possible, and industry and universities are great at coming up with all sorts of innovative ideas. But what we continue to need is a government industry partnership. Quite often those in industry that develop stuff may not be aware of the policy implications that what they develop has. So yes, we benefit greatly from aeronautically protected spectrum band that protect the safety and regularity of flight. Now, you can achieve that also in non-aeronautical or non-safety bands, but you create a very difficult situation in front of ITU. If we have decades of spectrum defense where we say, look, we cannot use commercial spectrum because it's not safety, etc., and then all of a sudden we come and say, oh, but we can do it because by now we figured out how to do it, that opens a can of worms in a lot of other areas. So I'm not saying it can't be done, but the matter needs to be looked at and presented very carefully. Because the kinds of proofs and the kinds of rigors that go behind in actually demonstrating that and defending that ITU, they're quite demanding, and we're not, in my view, dedicating enough resources to that part of it. So we like the whole innovation, new cool toys and interesting capabilities. What does it imply at the policy level when we're really expected to use less spectrum, not more? Those are important things to be addressed. And there we see that often some industry pushes ahead with some great idea at ITU, even aviation ideas. But if they don't do their homework right, they don't realize how to engage at ITU, quite often they damage the reputation of aviation in the process. And so that is something that we really need to avoid, just like we need to get used to. We used to be 20 years ago where we were the great guys that enabled people in the world to connect. We also need to start to become cautious of the fact that in terms of spectrum use, we're seen as the bad guys by some. In terms of environmental impact, we're seen as the bad guys by some. So we have to address these issues very carefully in a government-industry partnership.
So thank you, Gary. So, well, this is an important question about how to leverage the public-private partnership, and I would like to hear from Davis and Boris about how it can be actually utilized, and maybe the barriers can be broken down to ensure that we go through these barriers about spectrum. So Davis and maybe then Boris, your views, please.
I may not have fully captured the question, just implementation of public-private partnership thoughts. Is that a fair characterization?
Yeah, absolutely. Well, or if there is a need to work from a public point of view and work with the private partner, how can we work together actually to go through the barriers of spectrum that is difficult to allocate or implement?
Yeah, we have a lot of talks about that internal. So obviously, being a government agency and realizing how complex this full ecosystem is, pick any one individual use case, let alone all of them. I think in short, like, yeah, we're gonna have to formalize around all this stuff, at least on a domestic basis, country to country, with the different industry bases. I think, and it's got to be more than just like a set of people focused on, CNS. It's got to be the industry elements that also want to implement that stuff, the aircraft OEMs, obviously the airspace providers, and then working with the government agencies on implementation of that, proof of safety, proof of security, all the way through. In the US, the FCC, control of the spectrum and everything. It's a really complicated domain. It's also probably, arguably, maybe the domain that's caused some of the most issues over the years. So yeah, gotta have them, gotta start working them. I think first we have to lay out more of the high level requirements and what we're trying to accomplish out of these things. And I'm not sure in many areas of the industry that we're to that maturity level yet.